Hello students, welcome to the online math class 9 at Lead School at Home. In the last class, we learned how to find rational numbers between any two given rational numbers using the method of successive magnification. Today, we are going to cover day 10 of unit 1. Every day, you would be attending the online class and doing the homework for that day. You can then check your answers the following day. Make sure that you have downloaded the NCERT textbook and the supplementary book. Also, keep your notebook with you while attending the online class. So now, let us get started with the daily review of the homework from last class. So you were given homework from NCERT book as well as the supplementary book. Let us discuss both of them. So from exercise 1.4 in NCERT book, you had to solve question 1 and question 2. We will discuss question 1. Question 2 is also to be solved using the same steps up to 3 decimal places. So question 1 is visualize 3.765 on the number line using successive magnification. So first step is we will need to find out the integers between which this number lies. So this number lies between 3 and 4. So we draw this number line and we highlight 3 and 4. Now we will be magnifying this part and dividing it into 10 equal parts to locate the first decimal digit, which is 7. So we have divided this into 10 parts and we jumped 7 parts to reach 3.7. That is the first decimal place. Now we will divide this portion between 3.7 and 3.8 into 10 equal parts to locate the next decimal place, that is 6. So you can see on this number line we have divided the part between 3.7 and 3.8 into 10 equal parts. Now how many jumps will we take? 6, right? So 3.71, 3.72, 3.73, 3.74, 3.75 and 3.76. Now we will take this portion between 3.76 and 3.77 and divide it into 10 equal parts. So you can see we have divided it into 10 equal parts to locate the third decimal place, which is 5. So we jump 5 times to locate the given number, that is 3.765. So this is the location of this number on the number line. Now what kind of a number is this? A terminating decimal. So we have found the exact decimal number on the number line. Now the next question, question number 2, is a non-terminating number. So we will get an approximate location up to 3 decimal places for that number using the same steps. Alright. Now let us discuss the question from the supplementary book, practice question 6.3. So you had to find a rational and an irrational number between the following numbers. For irrational numbers, any answer with a non-terminating, non-recurring decimal expansion between the given numbers is acceptable, right? Because irrational numbers are non-terminating and non-recurring. So the first part is -5 and -6. So we will find the rational number by using the average or mean method. -5 plus -6/2 is equal to -11/2. So this is a rational number between the given two rational numbers. And as we discussed, irrational number can be any such number which is non-terminating and non-recurring. One example is -5.101, 001, 0001 and so on. Okay, this is one example. There can be other answers as well, but it should be between -5 and -6. Next part is square root of 8 and square root of 9. So if we simplify square root 8, we get 2 root 2, right? 2 multiplied by square root of 2, which is equal to 2 multiplied by 1.414, which is equal to 2.828. And square root of 9 is equal to 3, right? So rational number by using the average method is 2.828 plus 3/2, which is equal to 5.828 by 2, which is equal to 2.914. An irrational number we can take 2.973125416. So this is one example where the decimal is non-terminating and non-recurring. This was the second part. The next part is 0.05 and 0.005. So for rational number, we use the average method and we get the answer as 0.0275. For irrational numbers, one answer is 0.031, 001, 0001, and so on. Now the next part is 1 by 4 and negative 3 by 5. To find the rational number between these numbers, again we use the average method and we get the answer as negative 7 by 40. For finding the irrational number between them, we first convert them into decimals. So 1 by 4 is equal to 0.25 and negative 3 by 5 is equal to negative 0.6. By converting them into decimal numbers, we can now easily write an irrational number between these two numbers. So one answer is 0.201, 002, 00159, and so on. So these were the questions from the homework given in the last class. Now let us start with the topic of today's class. Now today we are going to recap all the concepts that we have learned so far in this unit. We will be doing this using some questions. I will show the questions to you on the screen and you have to solve them in your notebooks. These questions will be based on all the concepts that we have learned in this unit. So quickly, I am counting from 1 to 5. Open your notebooks. 1, 2, 3, 4, and 5. So these are the first set of questions. Spot the error in the following statements. So there are three statements given to you. You have to spot the error in each of these statements. You have 5 minutes to solve these questions. Okay? Your time starts now. Three more minutes. Last 1 minute. Last 5 seconds. 4, 3, 2, 1, 0. Let us discuss the answers to these questions. So the first statement is 2.6655555 and so on is an irrational number. Now what kind of a decimal is this number? This is a non-terminating recurring decimal. Non-terminating recurring decimal numbers are rational numbers. So this is a rational number. So this is incorrect statement, right? It is a rational number with a non-terminating recurring decimal expansion where 5 is the only repeating digit. Second statement is only fractions that can be expressed in the form p upon q are rational numbers. Now rational numbers are a set of numbers that only includes fractions that can be expressed in the form p upon q, where p and q are integers and q is not equal to 0. But also integers which are a set of positive whole numbers and negative numbers. So integers are also included in rational numbers. So this is also incorrect. This is the error. Only fractions are not rational numbers. Integers are also rational numbers. Now third statement is 1 by 2, 4 by 8 and 30 by 60 are all different rational numbers. What is the error in this statement? So if we simplify all these, we get them as 1 by 2, right? These all are equivalent fractions. So if they are equivalent fractions, they represent the same rational number, not different rational number. So this is the error in this statement. Now, these are the next set of questions. You have again 5 minutes to solve them. Your time starts now. 2 more minutes. Last 1 minute. Last 5 seconds. 3, 2, 1, 0. Let us discuss the answer to these questions. So the fourth statement is only 100 rational numbers can be inserted between 100 and 101. So we know that there are infinite rational numbers between any two given rational numbers. Therefore, there are infinite rational numbers between 100 and 101. Next statement is 1.111 and so on can be written as 1 bar. Now 1.111, this number can be written as 1.1 bar. The bar is placed only over the decimal digit being repeated. Since 1 is being repeated after the decimal point, the bar is placed over 1 after the decimal point, right? So the bar is only placed for digits that come after the decimal point. So this will be written as 1.1 bar. Now this is the next set of questions. Again, you have 5 minutes to solve these questions. Your time starts now. Last 1 minute. Last 5 seconds. 3, 2, 1, 0. Let us discuss the answers to these questions now. So the first statement is 3.56666 can be written as 3.56 bar. So what is the error in this statement? The bar is on 5 and 6 both. But which is the digit that is being repeated in this decimal expansion? Only 6 is being repeated, right? So the bar should be only on 6. It should be written as 3.56 bar. This is the correct way of writing it. The next statement is square root of 17 by square root of 7 is written in the form P upon Q. So it is a rational number. Now square root 17 and square root 7 are not integers. So even if square root 17 by square root 7 is written in the form P upon Q, it is not a rational number, right? Now this is the next set of questions. Again, you will have 5 minutes to do this. Your time starts now. 2 more minutes. Last 1 minute. Last 10 seconds. 5, 4, 3, 2, 1, 0. Let us discuss the answers to these questions. The first statement is any irrational number when squared gives a rational number. Now only the irrational numbers with square roots when squared give rational numbers. For example, square root of 5. If we square it, we get 5. So square root 5 when squared gives us 5, which is a rational number. However, cube root of 6, which is an irrational number, if we square it, we do not get a rational number. So this is the error here. Only the irrational numbers with square roots when squared give rational numbers, not all the irrational numbers, right? Next is 5.101, 001, 0001 and so on is a rational number with a non-terminating recurring decimal expansion. Now this is a non-terminating decimal expansion, but it is non-recurring because there is no pattern of digits which is being repeated. So it is an irrational number because it is non-terminating and non-recurring decimal expansion. So these were some questions which we solved in today's class to recap our concepts that we have learned in this unit so far. So today was a practice day. We practiced some questions, solved them in the class and discussed their answers. All these questions were based on the concepts that have been covered in previous classes. If you were not able to solve any questions in these questions, go through the concept times in your supplementary book and the NCERT book and try to solve them again. The homework for today is you have to revise all the concepts from the supplementary book and the NCERT textbook. We will meet in the next class. Bye. Happy learning.